Welcome to a solution stoichiometry problem with Ms. Taylor. This is a more traditional solution stoichiometry problem. This one's going to involve mass. We're going to take 25 milliliters of 4 molar hydrochloric acid and dump it on some zinc. It's going to bubble and fizz and produce hydrogen gas and then zinc chloride in aqueous solution. And we want to know that if we use exactly this much 4 molar HCl, what mass of zinc is required, and then to carry out what you may have previously learned, we're going to calculate the volume of the hydrogen gas produced at STP. So the first thing we need to do, remember when you're trying to get from one thing to another, you need a mole ratio. So you're kind of saying, okay, how can I get to moles from here? All right, remember that molarity, or whenever you say something's molar, is the number of moles per liter. Okay, so since we know the volume, which we can change to liters, 0.0250 liters of solution, we can then use the molarity and make sure that we put liters of solution on bottom to get the number of moles of HCl. And so therefore it's 4.00 moles of HCl. So liters of solution cancel, and we are left with moles of hydrochloric acid. And this is just a simple multiplication, 0.025 times 4. And you should get 0.1. Okay, so now that we have that, and we could also set this up to carry out as a long stoich, but I'm running out of space, so I'm going to start my next line here. Okay, now that we have moles of HCl, we can look at our balanced chemical equation and go from moles of one to moles of the other. So according to our equation, there are 2 moles of hydrochloric acid per 1 mole of zinc. But we don't want moles of zinc, we want grams of zinc, so we need to know the molar mass of zinc. And if you look that up on the periodic table, it is 65.39 grams. So in the calculator we are going to do 0.1 times 65.39 and then divide that by 2. And we round this to 3 significant figures, 3.27 grams of zinc. So we would need exactly that mass of zinc to react completely with our 25 mils of 4 molar hydrochloric acid. So the next question says, well, what volume of gas is produced at STP? Okay, again, we can work from the moles of HCl to get moles of H2, and because this is at STP, we can use molar volume. So let's write it out. 0.1 moles of HCl, and from our mole ratio, that there are 2 moles of HCl to 1 mole of H2. And because it's at STP, we can take advantage of molar volume, which says that any 1 mole of gas is going to take up a volume of 22.4 liters. Now, if this was not at STP, we would not be able to do this step. We would actually have to solve for the moles of H2 and then plug it into the ideal gas equation. But since we are at STP, it makes things a little bit easier. So in your calculator, you should do 0.1 times 22.4 and then divide that by 2. And that should give you 1.12 liters of H2 gas at STP. Thanks for watching.